Hello everyone, this is Dr. Rajesh and I am again with you with my new video lecture, and this video lecture is on numerical problem on projectiles. So in this particular video lecture we will study a numerical problem based upon the projectile study that we have done so far. So the numerical problem is given by, if v1 and v2 be velocities at the ends of a focal chord projectiles path, and u the horizontal component of the velocity, show that this thing we have to prove. And you may mark it as an important question from the examination point of view, and there is hardly any chance that this question does not appear in the examination. So firstly we shall draw the figure, and then we will see that what kind of figure comes out of it. Then we will proceed accordingly as per the given statement. Let me draw the figure. This is the vertical line that we have. This is the horizontal line that we have. Okay, and say this is point O from which the projectile is projected, and this is the projectile that is projected, and say this is the focus of the trajectory, and this is the chord passing through the focus and joining these 2 points, and say this point and this point. Now let us draw the tangent at these points. Say this point is A and this point is B. So these are the tangents at point A and B. So we know that whenever there are tangents drawn at the end of the focal chord, then and that tangents are at point at the end of the focal chord, that is point A and point B, then those tangents met at the directrix. So this point lies upon the directrix of the trajectory or parabola, and we know that those two tangents, this is a standard result, make an angle pi by 2 right angle at the directrix. So I can say that this is the directrix. Now we read out the statement again. If v1 and v2 with the velocity at the ends of a focal chord, A, B are the ends of a focal chord, and this tangent is giving the direction of the velocity. Okay, and say this is making an angle theta. So may I draw here the horizontal line. This angle is theta and this velocity is v1. This is the direction of second velocity, and if this angle is theta, so if I proceed it further, then in triangle, if I say that this point is C, in triangle A C B dash, sum of this angle and this angle is equal to exterior angle. So this angle should be pi by 2 plus theta and measured in anti-clockwise sense. This is also measured in anti-clockwise sense. Now again read out the statement. If v1 and v2 be these velocities at the ends of a focal chord or projectile path, and u be the horizontal component of the velocity, and we know that every time horizontal component of the velocity always remains the same, and u1 is the horizontal component of the velocity, and it will remain same in both cases. Here horizontal component will be same throughout the path of the projectile. Horizontal component always remains the same. Here at A, horizontal component will be u. Here at point B, the horizontal component will be same, it will be u. So resolving v1 along horizontally, we will get, resolving v1 horizontally, so we will get v1 cos theta, and that horizontal component is given to be u. This is u. Now if we resolve this second one, v2 is in this direction, horizontal is in this direction, so we have to take the angle in the anti-clockwise sense. So in that case we have to take this particular angle starting from here in the anti-clockwise sense and ending over here. So if you see, this angle is pi by 2 plus theta, and adding 180 to this total angle will be, now if I say 3 pi by 2 plus theta. Now this is in anti-clockwise sense. Now cos of that angle will give the uh, horizontal component of v2. So you may write v2 cos 3 pi by 2 plus theta is equal to u. This implies that v2 and cos in the fourth quadrant is positive, and sine 270 degree it will be sine theta is equal to u. This implies that sine theta is equal to u by v2, and cos theta is equal to u by v1. Now we know that scaling and adding we will get sine square theta plus cos square theta is equal to u square by v2 square plus u square by v1 square, and we know this is 1 is equal to u square by v2 square plus u square by v1 square. This implies that 1 by u square is equal to v2 square plus 1 by v1 square, and this was required to prove. So once again I am again coming back. We have resolved the components of this v1 which was in this direction, and horizontal is both are diverging from this particular point A. So we have taken the anticlockwise cos of the anticlockwise angle. Now here this is if we look at this particular point, that this is diverging and this is diverging, so we have to take this much angle. This is 270 plus theta in the anticlockwise sense. So that we have done. Horizontal component in case of projectile, we know that it remains the same throughout the motion. So this is same and given to be u. So then we have proceed further. So this is very important question from the examination point of view, and that's why I have taken it and made a video lecture upon this. So if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye, take care and see you soon.